You're writing manual date checks. That's why your code breaks on leap years. Most people try to split strings and check if months are under 12. It's a mess, and it's usually full of bugs. Checking dates by hand is a total nightmare. Between leap years and different month lengths, you'll almost always miss an edge case. We need a way that's built-in and bulletproof for every calendar scenario. First, we grab Python's standard date tool. Then, we set our expected pattern like year, month, day. We try to turn the input into a real date object. If it fails, we catch that specific error immediately. First, we bring in the datetime tool from Python's standard library. This is the gold standard for handling time because it knows all the calendar rules you'd probably forget to write yourself. It's much safer than raw string manipulation. We define our function and call its valid date. It takes a single string as input, which we'll try to validate. Keeping this logic in a small helper function makes your code much cleaner later on. Inside, we create a variable called dateFormat to tell Python exactly what we expect. Here, the %sign y, m, and d represent year, month, and day separated by dashes. You can change this to any format you need. We use a try block here because parsing can be unpredictable. This tells Python to attempt the next line, but be ready to jump away if something goes wrong instead of crashing the whole script. Now we use the method called strptime. It tries to convert our input string using the format we just defined. If the date is impossible, like February 30th, this line will immediately throw an error. If the parsing works without any issues, we simply return true. This means the string is a real, valid date that exists on the calendar. We're safe to use it in our application logic now. This stage makes the build feel real. If the string doesn't match our pattern or the numbers are impossible, Python throws a value error. We look for value error specifically so we don't accidentally hide other types of bugs in our code. Inside the except block, we return false. This provides a clean Boolean signal to the rest of our program that the input was bad. No crashes, just a simple true or false answer. Let's test it. We pass in February 29th for the year 2024. Since 2024 is a leap year, this is actually a valid date, and our function should handle it easily. Now we test it with February 30th. This date never exists, so Python will fail the parse and our function will correctly catch the error and tell us it's invalid. This is why we use built-in tools. When we run this, the leap year returns true while the impossible date returns false. It works perfectly every time without a single manual range check. No more breaking on leap years. Parsing a single string is basically instant. We aren't storing any extra data, so it's incredibly light on memory. Most importantly, it handles every calendar edge case automatically. The one thing to remember is the parser pattern. Don't write logic that Python already solved for you. Use built-in libraries to handle the messy edge cases so you can focus on building your actual app. Now you can stop writing manual date checks forever. Save this for the next time you build a form validator. Follow for more clean Python wins. CrackInterviewAI supports coding, system design, and HR rounds on Zoom, Meet, and Teams. Try it at CrackInterviewAI.in.